So, good afternoon, everyone. Welcome back after lunch. I hope that you are digesting well. I'd like you to relax, and I'm going to talk to you today about a syndrome that I like to call facepalm and carry-on insecurity. Now, before I get started, I need to tell you a little bit about myself. I've worked in IT for over 20 years, and about 10 years ago, I took a few applied cryptography courses, and I learned security is really cool. So I decided to make the switch, and I've been working in security for about 6 years now. And today, I'm going to tell you a tale of I's, O's, and T's. Now, if you're sitting in this audience, you probably know what that means. I'm going to be talking to you about Star Trek: The Next Generation and the Starship Enterprise, using IoT to boldly go where no man has gone before. So, what I mean by this, I started watching Star Trek: The Next Generation, a really old television show, this summer, and I started noticing that the Star Trek Enterprise uses a ton of Internet of Things. There are things like replicators, warp drives, you say computer, and the computer listens, and then you tell it what to do. There's the transporter, the holodeck, there's cloaking devices, the medical bay, where Dr. Crusher just magically waves the device over the patient, and then you instantly know what the diagnosis is. There is the ultimate interconnected implant society called the Borg. And finally, we have our very most favorite android in all of the world, Data. Now, when I say Star Trek, is there anyone here who doesn't know what I'm talking about? Okay, I see absolutely no hands in the audience, so I'm going to go on the assumption that we can assume we all know about Star Trek and move on. And so I'm going to tell you about Internet of Things. Now, if you're in this audience again, I know you know what IoT is. But for the sake of this presentation, I'm going to cover basically the architecture so that we're all on the same page for this presentation. Essentially, IoT is comprised of 3 different levels. You have the bottom level, which is basically the dumb level. This is a level where you have devices that are collecting information about the environment or giving commands in order to control the environment. In the middle level, you have your apps, and you have your gateways, and you have your edge computing devices. These devices collect information, process the information maybe lightly, and ultimately, they send that information into the cloud. In the cloud, there are three responsibilities. There's data analysis that can go on. There's service configuration, where you can actually configure devices to work the way that you want to. And if you're lucky, you get over-the-air updates. And so this is IoT. And the question is, are we building in security to a level such that we can drive a starship through the universe and actually be confident that we're not going to be hacked? And so to talk about this, I'm going to talk about 3 security fails that we've seen in the past year with respect to IoT. The first one has to do with Captain Jean-Luc Picard. He was really into drinking tea when he was thinking about problems on the Starship Enterprise. And in order to get that cup of tea, he would go to the computer replicator and say, "Tea, Earl Grey, hot." And then the replicator would create the cup of tea, and he would sip it. Now, today we don't have replicators to create our cups of tea, but we do have IoT tea kettles. And in the Hackable podcast from just a few months ago, they pitted IoT tea kettles against IoT coffee makers to see which would be the most hackable. I'm not going to tell you which one won, but what the hackers were able to do was to disassociate the tea kettle from the wireless network. Then they were able to force the tea kettle to associate to their rogue wireless network. Then they were able to connect to the configuration interface of the tea kettle, steal the wireless LAN password from the original network, and then connect to that network and be poised for further attack. So in this case, in this hacking instance, they were able to be in a local area sort of way, use a typical hack, and actually gain full access to the network, which is very bad. My next example has to do with warp drive. Now, when the Star Trek Enterprise goes into warp drive, it goes really, really fast. And it has the possibility of warp 1 all the way up through warp 10. And once you get past warp 10, then you run into problems with space-time continuum, but we're not going to talk about that today. We're just going to talk about regular warp. If you think about it, if you go really, really fast, there's no possible way a human can control a starship that way. You have to rely on sensors and some sort of positioning in order to make that work. Now, naturally, we don't have warp yet, but we do have positioning systems. And so the example that I'm going to talk about today has to do with vehicle trackers. So the Pentest Partners, a company in the UK, did their own research on 3 different vehicle trackers. Now, these are add-ons that you put onto your vehicle after you purchase it. And what it does is it allows you to track your vehicle in the case that it's stolen. Well, what they did was they investigated the APIs that allow the car to actually speak with the cloud-based tracking software. And what they figured out was, without authentication and without authorization, they were able to track other people's cars. In one instance, they were actually able to, without authentication and without authorization, immobilize a car completely. That's a problem. So in this case, it's no longer a local attack. This is definitely a remote attack, and you're actually able to influence things in the physical world. My third and final example has to do with smart homes. Now, if you think about the Starship Enterprise, it is the ultimate smart home. When you say computer, the computer listens to you, and then it does what you're supposed to do. Well, we have that today. We have smart locks, we have smart thermostats, we have smart baby monitors, we have security cameras, we have smart speakers. Everything is becoming super smart. The problem with that is, in the past year, there have been more and more reports of attackers actually connecting to people's smart homes and monitoring them in their homes, talking to them over their smart speakers. In some cases, there have been reports of attackers talking to babies in their baby cribs and monitoring the babies in their baby cribs. Another attack vector is that domestic abusers are now using these devices to control their victims. So when the victims are not at home, they turn up the temperature of the thermostat, causing higher costs for utilities and making it difficult for people to financially make it. There are also reports of they're changing the codes for locks so that people can't get into their home when they come home from work. So in this case, it's no longer just security researchers figuring out vulnerabilities. It's an actual real-life attack. Interesting in this case too, the attacks you're able to make these attacks because of weak passwords. So default passwords were used in those cases. Weak passwords were used, also passwords where people have reused passwords in other systems. Now, these are nice anecdotes, but what if we have a study that actually goes across just a few IoT devices? Well, a company called CyberITL did this, and they posted their results in August 2019. They went online and they downloaded 4,000 plus firmwares from 22 different vendors from over 15 years. And what they did was they looked for positive signs of security controls in that software. And what they found was this. There were no positive trends across vendors. And in fact, security vendors were removing security controls in their software. Now, when I see things like this, it makes me just want to facepalm and then carry on. IoT security is never, or IoT will never be secure. IoT vendors do not want to build security in. It's too expensive, it takes too much time, they have to get things to market. But on the other hand, we can't do that. IoT is coming, it's here, and it's only going to get more complicated. I haven't talked to you about the botnets. I haven't talked to you about the new implementations with artificial intelligence, the new implementations with robotics, and the potentialities of brain-computer interface. We need to get on board the Starship Enterprise and go with our IoT friends, or we're going to get left behind. So I started thinking about, okay, how can I approach this problem? Because it's a big problem. And for the past couple of years, I've worked in a related field, but not in IoT. I've worked in operational technology. And to me, operational technology is like IoT, but on steroids. And there are some similarities here, and bear with me as I explain what I'm talking about. So operational technology controls really big things. And what I mean by that is manufacturing, chemical processing, electricity generation, transmission, and distribution, which is where I've worked, water processing, oil and gas distribution, and at the very bottom layer, kind of like in IoT, there are some dumb devices. There are sensors that collect information, and there are field devices that actually control things like switches and relays and valves. At the second layer, we have smarter devices, but not super smart devices. These are PLCs, IEDs, and RTUs, and they collect the information from these sensors, and they send information down to the field devices. And then these devices in the middle send information up to the smarter systems. These are your SCADA systems, your distributed control systems. And these are the systems that prepare the information and make it consumable for the operators in the control room. Now, it used to be that operational technology was air-gapped. It was cut off. There was no connection in. In order to get into the control room, you had to walk into the control room. But more and more today, it's moving towards IoT, industrial IoT. And what that means is there are more and more connections into the control room from the outside. So there are remote connections with VPN for support personnel. There are mobile apps and web applications so that the business people can get up-to-date information about the process network so that they can make really good business decisions. And then you have cloud. Yes, we're controlling things with cloud. What could go wrong? Well, what can go wrong if OT is breached is much, much bigger than with IoT. You could have potential big environmental impact, death or injury, and if you damage equipment with an OT attack, you're looking at millions of dollars or euros of replacement. I'm not the first person who knows this. In the early 2000s, a bunch of countries said, this is a real problem, so we're going to put some legislation in place to make sure that we put security into these, into the operational technology networks so that we're protected. And so, for example, in the USA, the Energy Policy Act of 2005 was implemented, and this required electric companies in the United States to adhere to NERC standards, which have subsequently become more and more stringent over time. In Europe, there was the European Program for Critical Infrastructure Protection in 2004, and that was introduced in 2004, but really countries have started getting on board very recently. And for example, in Germany in 2015, they had an amendment to their energy sector law, which required companies to start implementing an ISMS and start implementing security controls. And Singapore just introduced something new just this year, their Operational Technology Cybersecurity Master Plan. I love the name Master Plan, and I'm very curious to see how things are forced to work in Singapore. To understand the legislation, though, you need to understand the different roles within OT. And these roles are asset owner, system integrator, and product supplier. Now, an asset owner is like the electric company. They use a bunch of things to control their network. On the right-hand side, we have our product suppliers. These are companies such as ABB, Siemens, GE. These are the companies that give you the devices that you can use to control your processes in your network. And then in the middle, we have this funny group called system integrators. And these are people who take requirements from the asset owners, and then they look for the product suppliers who are going to fulfill the process needs of the asset owner. And so where do you think the legislation placed the responsibility for security? They placed it on the shoulders of the asset owners and not on the product suppliers, which I think is very interesting. And this has led to a huge growth of security products and also services within the security industry targeted for OT. There are security audits, there's new products for monitoring, new products for access control, and new services for managing processes and keeping things up to date. Now, is this perfect? No. Are there still security problems in the area of OT? Yes. There are lots of things left behind, but we're seeing progress, and this is what I would like to see and what I'd like to continue to see more of. So if we map these roles from OT, the asset owner, system integrator, and product supplier onto IoT, what can we learn? And so I've broken down IoT into 3 different categories, because these are categories that come up over and over and over when I'm doing research. The first is medical, the second is connected vehicle, yes, our cars are full of IoT too, and consumer IoT. So in the first case, we have medical devices. And the kinds of devices that I'm talking about right now are implanted devices that control physiology in some way, or the kinds of devices that you use to measure your physiology so you can make decisions about your health. And in the asset owner category, we have just regular old humans. In the system integrator category, we have hospital, doctor's offices, and medical centers. And in the product suppliers category, we have medical device suppliers and component suppliers. And what's interesting in this case, in medical, is that there's movement in the area of security. And for example, in the US, there is the Food and Drug Administration. They are able to recall devices if there is a security vulnerability that they think is absolutely critical. And they've done so in the past. They're also in the process of putting together requirements for medical device product suppliers that specifies exactly what security controls need to be in place in order to be able to sell in the United States. Now, this hasn't been put into place yet. This document is in review, but the goal is to give something to suppliers so that they know what the expectations are with respect to security. In the EU, there's the medical devices regulation that was put into place in 2017. And it has some cyber security components to it. And devices need to be compliant with these requirements by 2020. So once again, is it perfect? No. But it's a start, and we're moving in the right direction. So the medical bay could potentially be a reality. So what about automotive? So once again, we'll start with our 3 different categories. Asset owner, humans. System integrator, you have auto dealers, service stations, relatives and friends who can actually fix things on your car. You also have product suppliers like OEMs and the ECU suppliers for the OEMs. And automotive is really interesting. They're not looking for legislation to legislate them. The Society of Automotive Engineers has put together a work group of representatives across the industry, and they're developing their own cybersecurity standard. So this is the proposed standard, ISO 21434, and it is slated to be ratified in 2020. So it looks like the automotive people have their stuff together, and they're moving in the direction of security. Now, it's not legislation, so it's going to be really interesting to see what happens once this is actually ratified and put into place, what the automakers are going to do. And now we're back down to the level of consumer IT. These are your smart homes. These are the things that you add on to your cars after you purchase them. And these are your smart tea kettles. What do we have here? In the asset owner, once again, we have humans. In system integrator, there's no formal system integrator here. You have package instructions, you have YouTube, Quora, Stack Overflow. People find information to get things to work in their homes in the most unconventional ways. And then you have your product suppliers, which are your IoT device makers, your component suppliers, and so let's think about the different ways that we could legislate. The first thing that we had in OT was legislating the asset owners. Meet your asset owners. This is Sally and Jim. Jim is retired. He likes to watch YouTube on his Roku device. Sally rooted her first tablet at the age of 65, and she has at least 6 devices connected to her network at home at all times. By the way, she's the network administrator of the house. But really what she likes to do is hang out with her grandkids. She doesn't really like futzing with the technical things. Are we going to force them to implement an ISMS? Are we going to fine them if they're not compliant? No. So we're going to move on. What about legislation for product suppliers, like in the medical IoT device realm? Let's look. We actually have an existing piece of legislation, people. This is in California in the United States. They passed a bill, the SB 327, and is going to go into effect in 2020. Is it going to work? My prediction is probably not. There's been a lot of criticism of this bill, in that it has a lot of good intention, but it's not specific enough for product suppliers to be of any use. And so if there is some sort of court case that goes on with this particular law, we're going to see the courts struggle to enforce it. We also have some proposed legislation in the US. There's a House Bill 1668. This is a bill that would require any IoT product suppliers that want to do business with the US government to actually adhere to a set of NIST standards which are currently under construction. In the UK, they've put together a code of practice for consumer IoT security, and it's a really explicit, nice list of security controls for IoT product suppliers. The problem is, they don't know exactly which controls they want to make mandatory because of reasons I'll talk about in a minute. And then in Germany, after the Mirai botnet problem, which knocked out my telephone for 2 full days, the German government, or the BSI, which is a part of the German government, put together a router security control list. And it's really nice. So if you go and read it, you're like, yeah, you're thinking about security here. It's not, or it looks like it could be enforced, but over time, talk about that has gone away. So I don't know what is going to happen here. What's the problem with legislation? Why is it so hard? Well, the 4 things that I've seen over and over again by looking at the different pieces of literature is that there's a lack of perceived criticality for consumer IoT. Now this is changing as real-life attacks start occurring more and more often, and legislators are actually very concerned about this. But then there's this lack of expertise. They know it's a problem, but they don't know what to do about it. And actually, there are several governments that have put together task forces to try to figure out, okay, how do we solve this problem? But it's still in process, and so it's taking some time. The next problem is that in the UK did a study to see, okay, if we implement these things, what impact is it going to have? What risks are we going to suffer? And the first thing that they said is it's going to negatively impact our small and micro businesses. So our startup companies who are trying to get out the next best things. Why? Security is expensive and it's hard. Then there's the next thing, monitoring costs. If I am a government and I put out legislation, it has to be enforced in some way. And so with millions and millions of IoT devices out there, how are they going to reasonably regulate and monitor and enforce these regulations? It's going to cost a lot of money. And so they have to get their heads around that and figure out what to do. So we don't have legislation for our product suppliers. We don't have legislation for our asset owners. What about standards? Let's write some standards and let's give them to the IoT product suppliers, and then everything is going to be great. Well, I did a search online to see, okay, what standards are out there? There are lots. Every reputable organization has put together their own set of standards for IoT security. So if I were an IoT product supplier and I knew nothing about security, if I were to go online and find all of these things, I would be overwhelmed. I wouldn't know where to start, and then I'd just think, I'm going to wait for legislation and they'll tell me exactly what I have to do. And so standards, because there's no de facto standard or no enforced standard, are out for the moment. So what do we do? IoT product suppliers, they're under a lot of pressure to deliver. And so it's causing them to cut out security. And so what can we do as a security group, as a security community, to help out these IoT people so that we can see security being built in, so that we can be on the Starship Enterprise where you say computer and then things happen and you know it's secure. Our first opportunity is with frameworks and the IoT application stack. So earlier in this presentation, I showed you the general architecture of IoT. And the first place that we can start is in cloud. There are already cloud frameworks out there for IoT that's going to make building IoT things much, much easier. It has configuration tools, it has data processing tools, and it has the ability for you to actually do over-the-air updates in a safe and secure way. The only challenge is we don't have a blueprint way of how to do it. So, if you have some time, or if your company wants to do some research and get your name out there, do some research on how to build a secure implementation within the cloud for an IoT device and publish it. Developers are not stupid. They want to do the right things. In fact, they're super duper smart and super duper resourceful. If you give them the information on how to do it and how to do it securely, they will follow. And even more, if you think about cloud, it's all code now. So if you want to build an infrastructure, you write a script and it builds the infrastructure for you. So rather than giving them instructions, write the code, check it into GitHub, and then let them download it, run, build their environments, and they'll have something secure to start with. With respect to software, interestingly, within the realm of IoT, there's some emerging real-time operating systems and lightweight operating systems that are used quite often. You have CoreOS, Ubuntu for IoT, Amazon Free RTOS, so on and so forth. If you want to help, make a reference implementation for an IoT device, and then give instructions on how to harden the environment so that people can start with a hardened OS core. With respect to the protocols in the local area network or the personal area network, you'll see if you start looking at IoT devices over and over and over again, the same components are being used. The same components for BLE, the same components for wireless. Get one of the test boards for these and create, once again, a mini application and then test it. And then report things that you find back to the vendors so that they can close the gaps so that we can have more secure components. And in the area of hardware, I'm still looking for ideas. Every single time I open an IoT device and look in, I see a lot of similar components, but they're often configured in different ways. So really what would be ideal is if we would have some sort of reference architecture that IoT manufacturers can actually rely upon that is safe and secure, that somebody has vetted, and all they have to do is build their functionality on top of it. There are other opportunities within the secure development lifecycle. One of the cool things from the Cyber ITL study that we looked at earlier is that they said there are a large number of duplicate binaries across multiple vendors, indicating a common build system or tool chain. If we knew what these IoT manufacturers were using when they were building their devices, we could help them secure the process. But right now, there's no large-scale study across the different providers to see what are they using, so we can't really help them. So if you are a company that has access to a lot of IoT providers and you can get some sort of information to help the broader community so that we can start building the tools to make IoT manufacturing more secure, do it. Get the information, publish it, and security will follow. Okay. And then we have our asset owners. Help them. So as we were talking about Sally and Jim, Sally likes to look on YouTube to figure out how to solve things. For example, her printer went on the fritz. She went into YouTube, she found a tutorial on how to solve the problem with the printer. She took the printer apart, replaced one of the pieces, put it back together again, voila, printer worked. We need something like that for security. For all of these devices that are being introduced, common devices in the homes, we need some sort of YouTube channel that basically says, this is how you set up the device as securely as possible in your home. The next idea is to have a consumer security review site. This would be a site that actually rates devices based on security. Consumers want to know what's secure and what's not secure. They love these kinds of sites because they're getting feedback about what they're about to put into their homes. There is a site already out there called the Internet of Shit Decks that kind of does this. This name would not fly with Sally, though. She wouldn't trust this site. What we really need is some sort of site called Consumer Security Review, something very boring but reputable, so that when she goes to the site, she can trust the information that is being presented there. There's also an opportunity for security tools for humans. There's a really cool tool out there right now called Princeton IoT Inspector. And what it does is it monitors your network for communication that is strange for IoT devices. It also monitors common IoT devices for weak passwords. So if we can build something that's going to help Sally very, very easily figure out what's going on in her network, that's a win for us. And then last but not least, in the situation with the smart home, where we had problems with weak passwords, reused passwords, the default password, we need some better way for authentication for these kinds of devices and services. I don't know what that solution is. I have absolutely no clue, but we need something like that. So if you're a security company or a security individual who has an idea of how to make this easier for Sally while she administers her network, please introduce it, bring it to the table so that we can get this problem solved. Now, so you're probably sitting in the audience saying, Jen has just told me to do a whole bunch of stuff, and it's not for a customer, and I'm not getting paid to do it. I have two answers to this. One, do it as a research and development opportunity in your company, publish the results, and when legislation starts rolling in for IoT devices, you're going to have evidence of your expertise in the field, and people will want to hire your company. That's the first answer. The second answer is the EU has recognized that this is a problem. And so they've actually put initiatives into place to fund researchers and small companies that are interested in doing work in IoT security. So take a look at the different places or the offers in the EU. If something matches what you or your company does, go for it. There are lots of other ideas that I have for potential solutions, but ultimately what I want is to make it a lot easier for our IoT people who are the small businesses and the startups to be able to deliver the really cool things so that I can go onto the Starship Enterprise and explore the universe. So that's all that I have for you today, with the one exception. I would like you to get out there and engage. Thank you.